Bro, I think I have every right to be depressed. I don't have anywhere, any safe space. And I'm not actually depressed, and I do have, anyway, so just, I want to take back. But, yeah, well, I guess there are it's in here that are like, don't say that, that's stupid. But I guess there are it's in here that really kind of, well, that. So can we just talk for a second? And also want you to keep me company while I work. So, already totally thrown off because not my father's fault. Well, not my father's fault that I'm thrown off. So let me share this with you first. Let's record screen. And there's a couple things I'm going to correct about what I said in this journal entry that are just not quite. But we can't spend too much time on it because I do have, we have stuff to do. So, all right. First of all, watch this video that I decided not to post on Instagram. Because I was like, oh no, maybe this is arrogant, and also it definitely looks terrible. So watch that. Can we just talk about how humble I am for a second? My dad is totally obsessed with, like, believing that consciousness is this amazing big mystery and looking at any explanation for it. Just refusing to consider illusionism or even try to understand alternative ideas about consciousness. What is the mystery of consciousness? What aspect of psychology, the mind's function, or the study of the mind, or consciousness, or what phenomenon do you not feel like you have an explanation for, right? And I'm already so annoyed that we're always talking about this. And look at that. So that's hilarious. I mean, I'm absolutely pleading with him. Bro, I'm too autistic, too ADHD to not be affected. All right, whatever. Let's just try to ignore it. Psychology has nothing to do with explaining consciousness. You can call it psychology. You can call it psychobiology. You can call it cognitive neuroscience. You can call it neuroscience. You can call it neuropsychology. You can call it chemistry. You can call it biology. You can call it molecular biology. You can call it physics. You can call it biophysics. But you should know that you've messed up when you type and send the sentence, psychology has nothing to do with explaining consciousness. At this point, either you don't know what you're talking about or you're just being obtuse. So that's that. First of all, I had this interaction with father. We had talked about it yesterday on the phone after he had sent me an email with an article. This article that he sent me an email offered a classical explanation for consciousness. A neural event, a macro scale neural event, like as we explain every other mental event. Anyway, so I called him. I was like, so do you understand now that we don't need to be talking about quantum mechanics? And he says something about, but it may explain this feeling of consciousness. So I sent him a text. I had to hang up. I sent him a text, though. I said, you know what? I no longer believe in sensory neurons. I said, I no longer believe in sensory neurons. Feelings of temperature are quantum events, not communication between peripheral sensory neurons and the sensory cortex of the parietal lobe. I'll bet phototropism in plants can best and completely be explained by quantum mechanics too. How else can they know where the light is besides knowing consciousness that pervades all cells, like my interviewees tell me? He said, are you deliberately misrepresenting me? I said no. I had forgotten that I had added that last bit about the knowing. See, he would never agree to a statement like that, but I swear that what he seems to believe corresponds to that kind of thinking of consciousness. Anyway, so he sends me these two articles. I haven't looked at this one, but I looked at this one. So then, so I want to nail down from him, what exactly is the mystery here? Because I remember you used the term, this feeling of consciousness. What is the mystery? Because the fact that I can talk about my own thoughts, not a mystery. The thoughts are neural events in here. Some of the neural events are language production. There you go. We know that there is interaction between all the different mechanisms here. The fact that I can remember things, no, we know about long-term potentiation, the hippocampus, sort of memory, not access, not recall, what's it called? Anyway, we know about working memory. You know, working memory is a thing that could very easily be sort of, like, we could, I mean, if you describe working memory, like, if you removed working memory from consciousness, I'm not sure you'd still have consciousness. You'd still, whatever is left, that you'd be able to say, yeah, that's consciousness. And so working memory is the ability to juggle a couple pieces of information at the same time, up to 7. We know that the prefrontal cortex is a sort of central hub that has many connections throughout the rest of the brain. That is not a quantum thing. That is the whole damn region of the brain with a whole bunch of axons and dendritic connections to the other pieces. And so it's no surprise that information from one piece can go into the prefrontal cortex and be compared with information from another piece because of all those connections that sort of go here. And that's an explanation that my dad has mentioned before. He talks about the prefrontal cortex as sort of the self. We have to understand it's actually distributed, but it is a major piece. That ability to juggle a couple pieces of information, to plan, blah, blah. A lot of that stuff happens here. Now, this isn't the entire self. It isn't the images that I experience. It isn't really my emotions. It isn't the feelings that I have. It wouldn't be the feeling of consciousness. Wouldn't be the prefrontal cortex or the frontal lobe. I don't think. So, I mean, that's what's so tricky. Consciousness, we just aren't even defining it. It's just like this ambiguous feeling that we have. So right. So I was asking, what aspect do you not have an explanation for? I can explain emotions, or I mean, I would have to Google it real quick, but I could basically give you the. I mean, there are still lots of unanswered questions, but I could give you the basics of emotion, feeling, mood, memory, taste, spatial sense, right? So that's another thing that's not here. So the feeling that we have of like existing in this body and like, this is not me. This is me, even though actually my brain's here, but this is me. This is not me. That sense, or if someone has an amputation and has a phantom limb, feeling like this missing structure is me. It is here. I feel it. And this ghost is not me, but this ghost is. All of that's up here. That's parietal stuff. Yeah. So I want to know, bro, am I recording actually? Yeah. I want to know, like, what could I Google for you to consider the possibility that consciousness might not be the mystery that you think it is? The mystery might be actually why it seems like such a mystery to us. We're not confused about Neo. We're just like, yeah, everything he does in his whole experience, I can explain with and say, oh, that's that area, oh, that's that network, blah, blah. So I said, what aspect of psychology or consciousness, or what phenomenon do you not feel like you have an explanation for? Psychology. Oh, I have the Instagram reel that you saw. Okay. So then I said some more stuff. Oh, no, I think I put this in the Instagram reel, but I didn't talk about it. So then I was starting to feel bad. Anyway, you can read this real quick. It's just frustrating because, of course, quantum mechanics could explain consciousness, but there's also a lot of good reasons to think that consciousness is perceived as a mystery, but isn't. That the mystery is just that it is a mystery. That, like, whoa, how come the brain has such a hard time accepting a classical explanation for the entirety of its mental events? Why does the brain feel so compelled to introduce some ineffable element or some not yet understood element? Why can't we be satisfied with neurons? That's really interesting. how did these neurons in these networks evolve such that the idea of seeing themselves as neurons in networks is so displeasing, right? Okay. Neuroscientists recognize both possibilities, and I would have liked to explain the second possibility to you. All right. So, and then let's see. And here's what I said. All right. So, I keep relivering the message about confident ignorance. Let's bounce why. Because no, not bounce. That should say nounce. I get corrected a lot on my own fucking. I mean, it's just my own thing. As though the dictionary in here. It's like, how dare you correct me on my own thing as though you know better. But actually, because it's my own thing, it wouldn't know. So, gosh, I'm funny. The mind is hilarious. And that just slipped out. I did catch it, obviously, but anyway, let's nounce. That should say why. Because it shapes hard. Wait, how do we distinguish between shaping in the sense of triggering its that dissent and hurt feelings? I guess we don't. We can't in real life anyway. Like if I say to you, what you just said, that shapes. I don't really know whether some rational it's in here were like, oh no, that's incorrect, or whether it bothered me for some other reason. So that has to be the question then. Does it show because it might hurt his feelings or because it is untrue? Well, Dad said that psychology has nothing to do with explaining consciousness. But it could. If consciousness, I mean, it's just so funny. The study of the mind has nothing to do with the study of consciousness. And maybe that's a straw man, but I don't see how. But it could. If consciousness were just a linguistic feat or a psychological illusion, a psychological labeling of distinct biological pieces, like we talked about the parietal lobe, the prefrontal cortex, the occipital lobe. Then we've got, right, the limbic system. We've got the amygdala, right? It's hard to imagine anybody thinking of consciousness without including emotion. And now maybe in the strictest sense, you could just define it as purely the awareness of one's own processes, in which case I'd say B, yeah, okay, let me get back to that. And A, the brain is not aware of all of its processes. I cannot tell you. No, there are a lot of processes that just aren't going to make it to the language cortex where it's going to come out. There's so many things happening in there that I not only don't know about, but probably maybe can't know about. And that's another part of the mystery. It's like, is it possible to increase consciousness by, this is good. Is it possible to increase consciousness without changing neural connections? So can I become more aware of the neural events without those events being more connected to the system? Because if I become more aware of a certain event and we see that a connection has changed, that mental event that I previously wasn't aware of, that I'm now aware of, we see that's now connected to something it wasn't connected to before, or there's some activity, whatever, then we say, oh no, classical macro scale, consciousness is all about interconnectivity. So it's maybe, whenever at least three things are happening at the same time: physical sensation, observation of a mental event, and visual activity independent of the visual stimulus, right? Now, if you have aphantasia, you're not going to have that third one, but you might have something else. Maybe we can say a feeling of continuity, which would involve the time and memory systems of the brain. So there's a whole list of things, and when we have two or three of these things, it feels like a conscious experience. So whenever two or three of these things are acting in coordination, it's a conscious experience. So what is coordination is the question. is it a quantum coordination, as in these neurons are not connected to these neurons, except they're quantumatically entangled? Or did we see, oh shit, they're both feeding through a structure now? And it's only when two or three things are either physically connect to each other directly or all feeding through the same network, so physically connected, that they are conscious. Okay? This has to be my last video on this topic because I think this is really clear. So, a psychological labeling of distinct biological pieces. He even said that he wants an explanation for the feeling of consciousness, but doesn't seem to consider that it might be a feeling. And a feeling is psychological, right? Or at least biological, right? It's an interpretation of the brain of peripheral neurons and chemistry changes and so on, right? Okay. Activity, okay. And this is the sensor myth / naive realism. Other examples of Dad presuming the truth of his senses is when he said that time slowing down isn't an illusion and that the brain literally slows down time. Or when he has described situations, this isn't an example, it's a category of examples, so it's kind of cheating, but when he has described situations with a low standard of evidence because the conclusions feel so true. In this case, I was thinking about a situation I didn't want to bring up. And when he believes so confidently, and I've talked about this in my previous videos about my dad, that Louise had some incredible facial memory, but actually it was not two different waitresses. Basically, there are these two women that look very similar. I thought that they were the same woman. Louise was like,
no, definitely not. I'm an absolute pro at this. I always, remember a face and I can distinguish blah, blah, blah.
And she said this after the woman said, "Oh, that was my twin," and that was the first. I'm pretty sure she hadn't said before that. I think it's two different women. She was just kind of confused because I was talking to the second woman as though she were the first woman. I think Louise was kind of confused. And then the woman said, "Oh no, that was my twin sister." And then Louise was like, "Yeah, okay, that's what I thought." And then was telling us about her facial abilities, that she can see someone. She doesn't know where she knows them from, but she knows that she knows them. I guarantee you, she's not testing that hypothesis. She's just believing it, that impression. Anyway, and so I said to my dad, I was like, okay, but it's also possible that there are faces that look familiar, and she doesn't actually end up finding out that she either doesn't know them, or there are a lot of faces that she misses, that she doesn't realize that she misses, that she knows. And he goes, "No, she said blah, 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 blah." And then the waitress came back and was like, "Oh, no, I was just kidding. I'm not a twin. I just put a scarf on." Okay, so I can feel bad about saying confident ignorance. All right. But also, his commitment to explaining the phenomenon of consciousness in resistance to considering it isn't a phenomenon at all belies his respect for science and neuroscience. He's missing out on a big chunk of the mystery. What does consciousness mean to us? In this video, we talk about a number of different ways that we can sort of describe consciousness. And a lot of them, I think, feel right. Could be a continuity of time. Anyway, we've talked about that. What explanations could satisfy and couldn't satisfy us? All right, well, here's an explanation that 100% satisfies us. Imagining ourselves as a soul, as an immaterial, and we can picture it as sort of just, gold dust aura right here or whatever. We can imagine it leaving us when we die. And that thing is it's crazy that it satisfies us because we don't understand. We have no explanation for, or no way to imagine, describe how that soul observes the activity of the mind, how it intervenes, etc. But it satisfies us. It absolutely shouldn't. It's a siren. But imagining ourselves, I mean, it's why humans don't, the question of consciousness is really only for people like interested in psychology and neuroscience. And now some people who are interested would be like, yeah, it's a mystery, but at the same time, they've got a pretty clear sense that there's this consciousness entity, no sense of the mechanics of it, but there is this conscious entity, and I mean, me too. I can picture a ghost, picture a little ghost, sort of observing myself and so on. Absolutely, bro. It should not satisfy me at all. But if you told me, oh, you know what consciousness is? That's your soul. Your soul isn't about feelings or memories. It's just the observance of those physical events. I think, all right, that makes sense. But it doesn't. And which explanations couldn't satisfy us? If I tell you consciousness, anything that you're going to describe as consciousness is biochemical events, not quantum events. You're gonna be like, yeah, but what about the feeling of consciousness? Yep, just like all feelings, it's a biochemical event. And it's a question of the architecture of the mind and the activity and the interactions. No, 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 no. I mean, I don't think you'd ever respond to that point. You just sort of try to get out of the conversation or something, So his commitment to explain the phenomenon of consciousness and resistance to considering it isn't a phenomenon at all belies his respect for science and neuroscience. He's missing out on half the mystery. Oh shit, sorry. Why is it that macro explanations are so displeasing, right? I'd rather imagine energy. We love talking about it as energy, maybe, right? Or quantum mechanics. Anything but imagining, like, cells explaining it. He sent me an article in which the researchers were wondering whether it's a classical or quantum phenomenon as evidence that we should consider the quantum possibility. But I want him to reread it as evidence that we should also feel comfortable with the classical. So let's look at that. I really don't think there is a mysterious complexity to consciousness. Maybe I'm just not conscious, eh? I mean, extraordinary claims like this just require extraordinary evidence. How is it that my father and I are going back and forth on this question? Why? And that's another part of the question of consciousness. Why is he so compelled by this controversial theory that's so many people are sort of uninterested in, that study the matter? Like, for instance, like the temperature, 37 degrees Celsius. Quantum computers currently operate at negative 272 degrees Celsius. Like, why can't my dad just be said? Why can't you just say, hey, look, but if consciousness is more than the evidence suggests that it is, it could be cool if quantum mechanics plays a role in it. And I'd say, yeah, okay, yeah. But then I'd also say, but here's the thing, Dad. You're one of the only smart people that I know will answer the phone when I call. So I would like to be able, because everybody thinks that consciousness is magic energy, whatever. Can we, but there's this really cool new possibility. All right, we're going to go back to that in a second. But there's this really cool new possibility. And we're going to look at this again. Skip if you've already seen this with me. I don't think I'm going to make too many comments. So, theories of consciousness typically address the hard problem. They accept that phenomenal consciousness is real. All right, I actually just pause it. And it's so funny because remember when we talked about this, he was like, Daniel Dennett errors, you don't know about, bro, illusionism, one of its powerful defenders is Daniel Dennett, bro. I hate that I have to, it seems like I should just be able to say, why do I keep thinking about this? Like, there's no need to keep thinking about this. But I just have too much humility that I have to keep running through it anytime anyone says you're wrong or says something that is different from mine. I have to keep running through it. All right, so anyway, so that's Keith Franklish. All right, so brain and fractals. And here's another thing. My dad and I can't talk about fractals. You know, my dad can pull out words that are used in discussions of quantum mechanics and understand like a couple things, but I mean, maybe he does understand more than me, but also I think he just thinks he does. I don't know. All right, so our brains are composed of cells called neurons, and their combined activity is believed to generate consciousness. Each neuron contains microtubules, which transport substances to different parts of the cell. Oh, you want to see something really cool real quick? Those are microtubules, I think. Just to put in perspective, so you're not imagining like a neuron is like a simple thing, bro. I think those are microtubules, or they just like fill a whatever. Okay, no. Are these our microtubules? Yeah. Awesome. Now, the way the brain works, very natural, very easy to imagine that walking dude is sort of being, anthropomorphizing that, it being an entity. But no, it's just a piece. It itself doesn't have a brain, a desire, knowledge, or anything. It's just repulsions and attractions between bonds and stuff. Carrying on. Oh, back to the article. Okay, so microtubules which transport that. The Penrose-Hameroff theory of quantum consciousness argues that microtubules are structured in a fractal pattern, which would enable quantum processes to occur. Already lost me. Fractals are structures that are neither two-dimensional nor three-dimensional, but are instead some fractional value in between. In mathematics, fractals emerge as beautiful patterns that repeat themselves infinitely, generating what is seemingly impossible, a structure that has a finite area but an infinite perimeter. Okay. I get how someone who wants consciousness to be magical would love that. Oh, I saw the word infinite. This might sound impossible to visualize, but fractals actually occur. Yeah, okay, fractals, great. Just like the borders of a country can be infinite depending on how you measure it. Yeah, infinite. Because even if you take every visual thing, not the borders of a country, but the coastline, where if you zoom in, you could go zigzag in a little bit. You could be more accurate. The structure of your lungs, blah blah. These are all examples of classical fractals that abide by the laws of classical physics rather than quantum physics. It's easy to see why fractals have been used to explain the complexity of. No, it isn't. These are all. No, it's not to me. Because they're infinitely intricate, allowing complexity to emerge from simple repeated patterns, they could be the structures that support the mysterious depths of our minds. The depths of our minds are, I mean, I can't, I'm not wrong, am I? like, it's just because consciousness feels and seems so complex and magical that we're looking at every corner to find an explanation for it, even if we have to ignore the fact of temperature and quantum elements, the fact that these fractals that this article has been talking about have all obeyed the laws of classical physics. Um, it's just the word infinite, literally, bro, because they're infinitely intricate. But consciousness isn't that amazing. It isn't infinite, bro. I cannot experience this beer can, bro. I cannot even experience all of the things that are happening in here. Again, maybe with. But again, I think that Buddhists and people, monks and shit, I think they have even more connectivity. In fact, isn't that what they say? Monk brain connectivity. I swear to God, if it says that there's already research saying that monks have more interconnected brains, because that's my only counter evidence right now, that monks are able to achieve sort of a higher consciousness, are able to feel more of their mind, are able to have imagine these out of body experiences, imagine sort of blah blah. Okay, let's go. Correlation between brain network connectivity. Correlation between the brain network and the monk resting state theta band and meditation experience. That's interesting. Brains of Buddhist monks scanned in meditation study. All right, hold on. Attention, that's another huge piece, which does involve the prefrontal cortex. That's another huge piece of consciousness. Dr. Josie Povich's research is part of a larger effort to better to understand what scientists have dubbed the default network in the brain. Oh, that's another one, the default mode network. Into two networks, the extrinsic network and the intrinsic. I haven't heard of this. Is he not talking about the default mode network? The extrinsic portion of the brain becomes active when individuals are focused on external tasks. Okay, yeah, and then there are self-referential ones, when individuals are focused on themselves. Yeah. But the networks are rarely fully active at the same time. Okay, blah, blah. Scientists previously believed the self-reflective default network in the brain is simply one that was actually presented. Okay. No, I know I'm skimming, but we just have other stuff. Now, this is interesting. So, during meditation, there are of course actually certain aspects of sort of consciousness that actually reduce. So your sort of presence in this moment and in this body, and your need to engage with the immediate surroundings, be aware of the immediate surroundings, those things actually decrease. So temporal frontal network connectivity in the EEG theta band was negatively correlated with the duration of meditation experience. So the longer that you were meditating, the less connectivity was seen in the EEG, electroencephalography. Overall, these data suggest that the neurorepresentation of cardiac activity in the DMN and large-scale spatiotemporal network integrations underlie the fundamental neuromechanism of meditation and further imply that meditation may utilize cortical plasticity. Yeah, this is what I've been saying. So, just wasting time, bro. We are wasting. Please tell me if that's not what I'm saying. All right, so it just seems so clear to me that, and it'll be clear in the future. You know, in the future, people will have no problem saying, "Oh my God, humans were so dumb. They were so obsessed with like consciousness being this super amazing thing that they were like, the only way it can be explained or understood is if it's infinite." But if this is the case, it could only be happening on the quantum level, with tiny particles moving in fractal patterns within the brain's neurons. You can't have consciousness without things being connected. I thought it was about like quantum entanglement. Are you talking about quantum events within a neuron? Within like each neuron? That's just pathetic. Quantum consciousness. We're not yet able to measure the behavior of quantum fractals in the brain, so we're really just reaching for absolute shit because we think so highly of ourselves that we can't be satisfied with classical or cellular explanations. We're not let me start that sentence again to finish it. We're not yet able to measure the behavior of quantum fractals in the brain, if they exist at all. They do exist in the brain, in the imagination that the brain's neural networks are producing. But advanced technology means we can now measure quantum fractals in the lab. You know, it's funny. I always thought I'll never be that guy that they talk about who was like, this is what's true, and and then I realized on my deathbed that it was wrong, but it was still a cool thing to have contributed and to have forced the people who disagreed with me to really investigate the truth, because if I'm not the one who, if they're the ones who have it. But this might be that issue. I think I'm open to, and maybe historians will be sympathetic. Eris did the best he could with the information he had. It did look like people just wanted to believe that there was a mystery. And then just after Eris left, we discovered blah 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 blah. And I can't say it with confidence because I don't even have anyone to really discuss consciousness with, to talk about what are some of these definitions and what are the biological correlates, and do we find a gap? In recent research involving a scanning, tunneling, a microscope, my colleagues at Utrecht and I carefully arranged, I thought that was in Germany, carefully arranged electrons in a fractal pattern, creating a quantum fractal. When we then measured the wave function of the electrons, which describes the quantum state, we found that they too lived in the fractal dimension dictated by the physical pattern we'd made. In this case, the pattern we used on the quantum scale was the Sierpinski triangle, which is a shape that's somewhere between one-dimensional and two-dimensional. This was an exciting finding, but STM techniques cannot probe how quantum particles move, which would tell us more about how quantum processes might occur in the brain. Okay, so then we went a step further. Using state-of-the-art photonics experiments, we were able to reveal the quantum motion that takes place within fractals in unprecedented detail. What does this have to do with the mind? This could provide the foundations for scientists to experimentally test the theory. If quantum measurements are one day taken from the human brain, they could be compared against our results to definitely decide whether consciousness... So I admit I don't understand how, because we skimmed it, but maybe you did, in which case please explain in the comments. I see. So they, in this article, must have described some quantum activity that is different. Here we go. I see. Our observations from these experiments reveal that quantum fractals actually behave in a different way to classical ones. Specifically, we found that the spread of light across a fractal is governed by different laws in the quantum case compared to the classical case. just seems so stupid. So, like, everything in psychology, we're talking classical neuron interactions. So, and you've seen fractals that obey classical physics. You've also seen fractals that obey quantum physics. You've seen those on the quantum level, in the quantum realm, and at a certain temperature. What justifies the move to going, maybe this explains consciousness? The only thing that could justify that is if you are unsatisfied. And the only with classical explanations, the only reason you're unsatisfied, I mean, they don't say in this article, like, in psychology, we've understood so much about the self. We've got the default mode network and attention. We've got the parietal lobe. We've got visual activity. We've got all this. We've got the posture. We've got all this incredible stuff. But gosh, we're just so stumped as to how humans can what? No, it's just a experience that you have. It's not real. I mean, experience is real, but you're misinterpreting the experience. All right. So then, all right. Oh gosh, this took too long. I do feel bad about not clicking on the second article, so let's do it. I was going to say, but we're not going to do it. The role of biophotons... Oh, fuck, I did not mean to do that. The role of biophotons in the brain is a growing area of research in neurobiology, and where there are photons, there might be quantum mechanics. The light of the mind is blue. It actually seems to be red. That's because recent research suggests a link between intelligence and the frequency of biophotons in animals' brains. In 2016, Zhuo Wang and colleagues at the South Central University for Nationalities in China studied brain slices from various animals, bullfrog, mouse, chicken, pig, monkey, and human, that had been excited by glutamate, an excitatory neurotransmitter. They found that increasing intelligence was associated with a shift in the biophoton's frequency toward the red end of the spectrum. Admittedly, it is unclear what the measure of intelligence actually is, and the study has drawn criticism for its lack of an explanatory mechanism. Correlation, as the mantra goes, I mean causation. However, the role of biophotons, now they define it, spontaneous, ultra-weak, near-ultraviolet to near-infrared photons in biological systems. Light has such symbolic resonance for humanity. Yeah, no kidding. We would love to be able to see the soul as light, and we already do. So people are going to love this article. We speak of enlightenment and seeing the light, for example. It seems fitting, therefore, that it might play a physiological role as well. No, it plays a psychological role. It's your psychology that makes it. We associated light with the soul and truth and magic and so on, and we're just doing it again. Just how light is involved in the signaling process that constitute the central nerves. I mean, okay, light.
Go away again. You'll see it says emergent property consciousness, not emergent phenomenon.
I'm confused. It's not my thing. But yeah, light, neurotransmitters, microtubules. Yes, these are all the pieces, but consciousness is the sum. It is not an inherent piece. Yeah, no kidding. While the weirdness of quantum theory has lent itself to some unhelpful pseudoscientific interpretations of consciousness, there has been resistance from scientists to yoke the two together. What do you mean, while? While the weirdness has lent itself to some unhelpful... Just because both subjects are difficult to understand does not mean that they necessarily inform each other. Despite this, the first detailed theory of quantum consciousness emerged in the 1990s. Penrose and Hameroff. Their orchestrated objective reduction theory has undergone a number of revisions since this, but generally it posits that quantum computation cellular structures known as microtubules have an effect on the firing of neurons. And yeah, sure. And by extension, consciousness, because consciousness is about the firing of neurons, the interconnectivity of neurons. So anything that helps with the firing of neurons, yes, is a piece of consciousness. Yeah. Yeah, okay, so yeah, I mean, yeah, neurons have a quantum level, and there are quantum things that might be happening, but how is this, like, new then? How is this... We're not actually explaining consciousness, because if you start disconnecting the cells, and you have 80 billion, because I say 100 billion, but that's what we start with, and a lot of them get pruned away. So I saw 80 billion recently, so I should say 80 billion. Anyway, you take the 80 billion neurons and you separate them, but somehow, keep them in a little gel so they're alive. You can have all the quantum activity and all the firing you want. There will be no consciousness. Or at least I don't see any reason why we should think that there is. And then really just how are we defining consciousness at that point? And the theory elicited a number of criticisms, perhaps the most damning followed from the fundamental tenets of quantum theory. A quantum system, which might refer, for example, to the dynamics of a proton, is a delicate thing. Conventionally, quantum effects are observed at low temperatures where the system is isolated from destructive interactions with the surrounding environment. This would seem to exempt quantum effects from playing any role in the fuss and mess of living systems. Biological systems such as the brain operate at physiological temperatures and are unavoidably bound to their environments. As calculated by physicist Max Tegmark of Princeton University, quantum effects would not survive long enough to have any influence on the much slower rates at which neurons fire. All right. However, this objection has to some extent been mitigated by research done in the broader field of quantum biology. The application of quantum theory in a biological context has had most success with regards to photosynthesis. We had mentioned phototropism, but research on the avian compass. Okay, how birds know where they're going. On the avian compass, olfaction, enzymes, and even DNA also suggests that quantum effects might be implicated more generally in the functioning of biological organisms. By the way, let's distinguish between might and may, please, just because I'm sorry to do that, but my teacher taught me might is for a mighty small chance. Okay, so it's really just introducing a possibility. And I really don't see evidence for the possibility. I just see the need, the demand. Might be implicated more generally in the functioning of biological organisms. Okay. All right. So we've got two neurons here. We've got a little gap between them. So there's a little gap there. A little gap between them. We've got these, what do you call these? Vesicles, which bleb. That word's not on there. Bleb. And release these neurotransmitters that land in the receptor. Just gonna open a little doorway for some calcium and shit to move around between the inside and the outside of the cell, which is gonna change the charges, because if you have positive calcium leaving, positive potassium leaving, negative sodium, anyway, it's going to change the things, the cell, polarity, and anyway, attraction, repulsion. Okay. So quantum effects in the brain might be better phrased as quantum effects in neural processes. Yes, that is better. For which this diagram of a nerve cell serves as illustration. Nerve cells consist of three main elements: the cell body, which contains the various organelles, dendrites, which receive incoming signals, and the axon, which transmits the signal. It is thought that signals are passed between nerves when the axon terminal meets the dendritic bulba. As a signal moves through a nerve, it triggers the release of neurotransmitter signal. Receptors in the neural opening ion channels. That's what we were just talking about, opening ion channels, and thus altering the next cell's membrane potential, passing along the signal. Calcium is definitely 2+. I'm going to be distracted by this. An ion charge. Yeah, 1+. And then sodium must be 1-, yeah. Oh, no, it's 1 plus. Oh, chloride. It's sodium chloride has 1 minus. Okay, we don't even need to, yeah. Okay. Okay, it trigger as a signal moves through blah blah blah. Nerve constituents that are important to discussion of quantum events are effects of the microtubules, which are formed by the polymerization of a protein known as tubulin, and the mitochondria, often described as the powerhouses of the cell. Microtubules give structure to the cellular cytoskeleton and are necessary for cell division as well as the movement of motor proteins, a group of proteins that convert chemical to mechanical energy. The mitochondria use electron transport chains, I see, and proton gradients to create adenosine triphosphate, which powers biological processes. They are also the proposed primary site of biophoton production. In a trivial sense, all biology is quantum mechanical, just as all matter is quantum mechanical. It is made up of atoms and thus subject to the physical laws of atomic structure first formalized by Bohr at the beginning of the 20th century. The focus, I don't think I read this sentence right. In a trivial sense, all biology is quantum mechanical, just as all matter is quantum mechanical. But then he talks about, the physical laws of atomic structure, not, okay. Okay, the focus of quantum biology, however, is on key quantum effects, those quantum phenomena that seem to defy our classical imagination, such as superposition states, blah, 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 blah. Entanglement, yeah. If this is the what of quantum effects in the brain, the where is more straightforward. The brain is made up of neurocells, elongated cells consisting of cell puts information is passed to and from the brain by the firing or not firing, a process of that. This potential depends on the spread of charged ions in order its resting potential. How the signal then passes is still a matter of debate, but they such theories that it's managed by chemicals. Obviously. Altered states of consciousness might be interesting. What better way to study consciousness than by looking at it in altered states, specifically the chemicals that achieve this, such as general anesthetics? Yeah, bro. You tell me alcohol changes my quantum shit? Turin noted that chemicals with anesthetic capabilities have chemical and structural properties that are very different from each other, leading him to focus on the similar physics that these substances might share. Okay. Anesthetics can bind to various cytoplasmic and membrane proteins. He proposed that anesthetics facilitate electron currents in these proteins and that this might be demonstrated by looking at changes in quantum spin. Okay. Where spin describes the magnetic properties of quantum particles such as electrons. What he found was that under the influence of xenon, the simplest of all the anesthetics, fruit flies showed an increase in electron spin as measured through the use of, that's very weird or interesting. I guess is sort of that's like the most supportive sentence I've read. I'm not also wondering whether, because still, like, what could, but how did you know it was an alternative? Oh, because if anything, if you give an anesthetic to something, that will alter the consciousness of any biological. Okay. Because what's in an anesthetic? So xenon is the element, I see. Wait, I'm shocked that anesthesia could be an electrical thing. I would have assumed that you were just like blocking, you're introducing an antagonist to certain systems of awareness or agonist to certain systems that go the fuck to sleep. This is exciting. I will grovel. No, I won't, because my dad's not very good at discussing things, and I don't think he's ever said this. I mean, he sent this article, but I don't know that he really. Anyway, this effect is achieved by administrating blah blah, which often act in combination with an analgesic and neuromuscular blocking agent. a neuromuscular blocking agent. That would be an antagonist to neuromuscular, you know. Spontaneous ventilation is often inadequate. Okay, biochemical. Where's quantum mechanism of action? All right, biochemical mechanism of action. Oh no, that's not what I wanted. The biochemical mechanism of action in general anesthetics is still controversial. Theories need to explain the function of anesthesia in animals and plants. To induce unconsciousness, anesthetics have myriad sites of action and affect the central nervous system at multiple levels. General anesthesia commonly interrupts or changes the function of CNS components, including cerebral cortex, thalamus, reticular activating system, and spinal cord. Current theories on the anesthetized state identify not only target sites in the CNS, but also neural networks and arousal circuits linked with unconsciousness. Some anesthetics potentially able to activate specific sleep active regions. That's what I would think. Yeah, and then we have GABA, our inhibitory neurotransmitter. Glutamate, our excitatory one. Protein-mediated molecular targets. Okay. Yeah, so they either enhance the inhibitory transmission or reduce the excitatory transmission of neurosignaling. Yeah. Okay. So when do we get to talk about how electrons spin and some bullshit? I mean, anesthesia, it's an element. And what this xenon is going in and changing the electrons sound like such nonsense. Anesthesia has little to no effect on brain function. What are you talking about? Unless there is an existing barbiturates or the drugs used to administer do not affect auditory brain stimulus. Brain disruption would be a concussion. No effect on brain function? How can you say this? No effect on brain function. The person is no longer feeling the things happening or able to engage with you. That's brain stuff. You mean no permanent effect? Okay, you're just talking about no permanent effect. It's so dumb. Alright. Emergence. What's this? No, okay. When you come. Oh, yeah. Well, let's look at what. So, emergence, the return to baseline physiological function of all organ systems after the cessation of general anesthetics. This stage may be accompanied by temporary neurological phenomena, such as agitated or acute mental confusion, aphasia. Yeah. Aphasia. Impaired. So, that's going to be our Broca's area. Acute mental confusion, and that's just going to be all over about how they're interacting. Yep, sensory, motor. I hate how much time I'm wasting on this. All right. Anyway, so let's just go back to what I said. So he sent me an article in which the researchers are wondering whether it's a classical quantum phenomena. Blah, blah, blah. And okay, if consciousness. Oh, so here's another question that's part of the mystery. If, because we have to be open-minded when we don't have conclusive evidence, if consciousness isn't a word that refers to a unique identifiable thing, whether that be the way the things are, electrons are spinning, whereas for me it would be, it's more of a diagnostic checklist, sort of like we're talking about. Anyway, if it's not that, then there might be differences between my consciousness and yours, right? Because this word consciousness exists in all of our minds. Anybody who's learned the word, it doesn't mean the same thing. It's kind of like the discussion about whether my red is your red. So, because I swear, for me, consciousness, attention, but a huge part of it is how these images are really existing in here, such that right now I'm looking at that image from a second ago. That feels magical. That feels like consciousness. All right, for instance, I have visual consciousness. I am regularly perceiving myself as though from above or beside. I have rich internal visual experience. He sent another article that presented, and he does not. He sent another article that presented a classical partial explanation of consciousness as being the relivering of visual information in the occipital temporal. That's what he had emailed me that started our latest conversation, because I was like, so do you believe me now? My hair looks so good, I think. Presuming that consciousness is a special mental phenomenon that needs quantum explanation, unlike all other mental events for which we accept classical explanations, is ignorant of today's perspectives on the mind and consciousness. And confident ignorance because of its immunity to information I shared with him, like the article on illusionism, which we saw, the work of Gerald Smallberg. Right, there's two I'm looking for. That one of them is early, I know that for sure. There it is. Page 87. Page 87, page 87. And you know what? Because it's never marked. Page 87 and page 285. Page 87, page 285. 87 to 285. 87. Okay. Okay, so what's my favorite? V.S. Ramachandran, what's my favorite elegant idea? The elucidation of DNA structure is surely the most obvious, but it bears repeating. I'll argue that the same strategy used to crack the genetic code might prove successful in cracking the neural code of consciousness and self. And then it's God is a hacker. Many a young biologist has slit his own throat with Occam's razor, yet his own solution to the riddle of heredity ranks with natural selection as biology's most elegant discovery. Will a solution of similar elegance emerge for the problem of consciousness? It is well known that Crick and Watson unraveled blah 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 blah. Okay. After his triumph with heredity, Crick turned to what he called the second great riddle in biology, consciousness. There were many skeptics. I remember a seminar Crick gave on consciousness at the Salk Institute here in La Jolla. He'd barely started when a gentleman in attendance raised a hand and said, "But Dr. Crick, you haven't even bothered to define the word consciousness before embarking on this." And if you watch the video where I've read this chapter, I said, that would be me. And Crick was like, "Oh, we leave the matters of semantic hygiene to you philosophers." Okay. Crick did not, in my opinion, in Ramachandran's opinion, succeed in solving consciousness, whatever it might mean. Nonetheless, he was headed in the right direction. He had been richly rewarded earlier in his career for grasping the analogy between biological complementarities and the notion that the structural logic of the molecule dictates the functional logic of heredity. Given this phenomenal success using the strategy of structure-function analogy, it is hardly surprising that he imported the same style of thinking to study consciousness. He and his colleague, Christoph Koch, did so by focusing on a relatively obscure cluster called the cluster. Now, here are the two paragraphs that are important. The claustrum is a thin sheet of cells underlying the insular cortex of the brain, one on each hemisphere. It is histologically more homogeneous than most brain structures, and unlike most brain structures, which send and receive signals to and from a small subset of other structures, the claustrum is reciprocally connected with almost every cortical region. And that's what made the prefrontal cortex also such an attractive hub of consciousness, because of its connections. The structural and functional streamlining might ensure that when waves of information come through the claustrum, its neurons will be exquisitely sensitive to the timing of the inputs, and that so then you have the sequence of events, you have this feeling of things happening at the same time, or is one thing happening after another. And especially if you have that feeling of one thing happening after another, you'll feel like a single entity that is moving from this action into that action to that action. Whereas it's like, this is happening here, this is happening here, this is happening here. But if this happens here, runs through here, this happened here, not related to this, they aren't related, then this comes in following next. Watch my video on N liveries. That's related. Okay. So what does this have to do with consciousness? Instead of focusing on pedantic philosophical issues, Crick and Koch began with their naive intuitions. Consciousness has many attributes: continuity in time, a sense of agency or free will, recursiveness or self-awareness, etc. But one attribute that stands out is subjective unity. You experience all your diverse sense impressions, thoughts, willed actions, and memories as a unity, not as jittery or fragmented. This attribute of consciousness, with the accompanying sense of the immediate present or the here and now, is so obvious that we don't usually think about it. We regard it as axiomatic. I just don't understand how that's not compelling, what's being said here. And then we're just going to read one paragraph from The Wizard of Oz, Gerald Smallberg. He's a practicing neurologist, okay? So he does not identify as a psychologist. He's a medical doctor. He's a practicing neurologist, okay? Consciousness is the fusion of immediate stimuli with memory that combines the simultaneous feeling of being both the observer and the observed into a smooth, enveloping flow of time that is neither truly the past nor the present, but somehow inexplicably each of them. Whatever the final answer turns out to be, I suspect it will be an illusion. The mind evolved to hide the messy workings of its parallel modular computing. Parallel modular computing, and then being interpreted as happening causally in one after the other. And then his evidence for that is fantastic. It's the isocods. But anybody who follows this channel, I've talked about it enough times. But that's in the playlist. This explains everything. Mind chapters. Okay, next. And confident ignorance. All right, the article on illusionism, the work of Gerald Smallberg, the last thing we looked at, and the discussions of V.S. Ramachandran and Francis Crick, and I hadn't realized Crick and Koch, bro, because I thought Christoph Koch was like, he's all about the magic and stuff. He's like the preeminent